Hello, my dear students. Good afternoon. Good afternoon, my dear students. Hello, very good afternoon, my dear students. How you all are doing? I hope you're doing fabulously fine. So, as a beginner, please remember to keep the quality of the video set above 240p. Then only you will be able to see a clear picture or clear video. Okay, so this is one simple advice to everyone. I hope you all are able to hear my voice properly. So, as today we are set to discuss on moving charges and magnetism. So, let's go ahead and have a look at moving charges and magnetism concept, my dear students, quickly. Irana, very good afternoon. Uday Kumar, Uday, very good afternoon. Vinod, good afternoon. Indira, Sheetal Umarji, Janvi, very good afternoon. Bevur, SR Bevur, very good afternoon. So, as a matter of fact, we are at the level of starting off with the class now. Okay, let me begin the session, my dear students. I would like to see your messages so that it will be uh, a go ahead signal for me. Shall we begin with our session, my dear students? Okay, fine. Now let's start off immediately with our session, my dear students. So, to begin with, I'd like to give a brief intro about me so that those who are joining the YouTube live sessions of Unacademy today, this is my brief experience. I have taught JEE Advanced and JEE Main Physics for closely about 19 years at various locations like Delhi, Kota, Bangalore, and all across India, pan India, and taught to closely 10,000 plus students till date. And currently, I'm working at Prarthana PU College in Karnataka, and this is eventually the third ongoing month on an academy for me. Okay, so this particular platform has been one of the highly lucrative platform for me as well as you all students, my dear students. So we have learned so many good things under this particular session. So let's go ahead and begin our discussion on moving charges and magnetism. But prior to that, let me just give a brief intro about our plus subscription. Okay, so as we all know, Unacademy has a plus subscription plan, and this plus subscription plan, it always gives me a pleasure to introduce. Now we have got for Karnataka CET, the best plans that are available right now presently for Karnataka CET 2021. Okay, those who are planning for Karnataka CET in the year 2021, that means those students who are in class 12 presently or PUC second year, for them this plan is laid out, and you have a 12-month plan which is costing at 12,375. Okay, so this is a 12-month plan which approximately costs you 1031 rupee per month. Then we have a 6-month plan. Now this 6-month plan, this is actually for 10,125 rupees, and this works out approximately 1,688 per month. Okay, and we have a trial plan, that is 1 month trial plan, my dear students. And this 1 month trial plan, it is 2,250 rupees. Okay, this is for new subscribers only. Okay, not for everyone. Those who have already subscribed, for them this 1 month plan is not applicable. Okay, so now what we get out of it, we usually uh, apply or take something with some benefit in mind. So what we get out of this particular subscription, so we will get a comprehensive batch. Okay, a comprehensive batch, a live batch for the complete syllabus, my dear students. Complete syllabus, that is most important, right? Then we can also avail some of these beneficial options. So one is like this, the premium content that you can get at a very affordable price. Okay, then we always cater a structured live courses. Live courses are always well structured, my dear students, and dedicated live doubt clarification sessions are most predominant on Unacademy, and quizzes are always at regular intervals to boost the morale of every student for self analysis. Then for complete preparation itself, we have batches. We don't have like only physics, only chemistry. We will provide you a complete set of all 4 subjects or all 3 subjects for Karnataka CET. Then test series, if we just talk about test series, uh, I can say that the DPPs, daily practice papers, are definitely the boons. Okay, and we have full length mock exams. Okay, and each of these mock exams and the DPPs are always provided with analysis, my dear students. And here, a single subscription will give you unlimited access. That is the most important thing, right? So one single subscription, you can get what all things. First thing, all the plus classes on Unacademy platform. Okay, all YouTube live sessions. Okay, then you will get quizzes, you will get DPPs, full length mock exams with analysis. Now these all things act as a package, and suppose if you just consider each of them separately, that will cost very high in the market. But for Unacademy, we always believe in catering good quality education at a very low cost. Okay, so that is the plan. So this is Unacademy plus subscription regarding that, my dear students. Okay, now let's go ahead and take a look at few more things. We have so many guests here. Janvi, very good afternoon. Indra, Vinod, Iranna, Uday Kalmat. Okay, all of you are welcome to this particular session, my dear students. Okay, now let's begin with our discussion on moving charges and magnetism. Okay, and I almost forgot to mention. So, if you want to avail a 10% discount on the subscription, just go ahead with UTTAMLIVE. This is my uh, referral code for YouTube classes, UTTAMLIVE. Huh? So you can utilize this and go ahead with the benefit of 10%. Okay. Now let's begin with our discussion. Now here goes the first question. Three long straight wires A, B and C are carrying current as shown in the figure. Then the resultant force on B is directed. Okay. Now over here, as you can notice, A, B and C are three long conductors. They are carrying currents of 1 ampere, 2 ampere and 3 ampere respectively, and their directions are same and distance between them is D. Okay, so from this, if we just try to grab the concept of force between two conductors, that concept if you just try to grab, remember that the force between two conductors, two parallel conductors, is F by L, that is force per unit length of the conductor, is equal to mu naught by 4 pi into 2 I1 I2 by A. So mu naught by 4 pi into 2 I1 I2 divided by A. This is the formula, and from this I can notice that very clearly force is directly proportional to product of the currents. Okay, so now if I consider force on B due to C, force on B, force on B by the virtue of C, what will be the product of currents here? 2 into 3, that is 6. Okay, and force on B due to A, if I calculate, it is 2 into 1, so product is 2 here. So obviously we can say that the force on conductor B due to C is greater than force on conductor B due to A, because current product is more in between B and C, and as compared to the current product in between A and B. So hence we can say that the net force is on B and it will act towards the C, because C is carrying more current, and thus the resultant force, if I calculate, I tend to know that FBC will be greater than FBA. So clearly the direction of the force will be towards C. Okay, so hence we can comfortably go ahead and mark the answer as option C here, right? So you all are attentive, right? So you all are able to understand this particular solution. Any particular queries, kindly type in here. I am just observing the chats, my dear students. If you have any queries, any doubts, fine. Okay, I hope so. You are clear with this. Now let's move on to next question. Question number 2. Okay. Second question. A conductor in the form of a right angle triangle, right angle ABC, with AB is equal to 3 centimeter and BC is equal to 4 centimeter, carries a current of 10 ampere. There is a uniform magnetic field of 5 Tesla perpendicular to the plane of the conductor. The force on the conductor will be. Okay. Now this question, they say that a conductor is a uniform right angle like this. Okay. So they say that this is A, this is B, and here we have C. And they say that AB is 3 and BC is 4 here. That is what they have mentioned, my dear students. So accordingly, let's go ahead and crack this question quickly. Now, I can consider this right angle beam like this. That means the resultant of AB and BC would be what? AC. So I can consider a conductor being placed along AC, okay, with a length of how much? 3 square plus 4 square, that is 5 square. Okay, but let us not concentrate on the length here, and I can replace this right angle beam by this one single conductor, correct? So obviously this will provide me a force like this. Okay, so in this direction towards B the force will be there, because magnetic field vector B is perpendicularly inward. From this we can comfortably see that the direction of force will be in this direction. Okay, so hence from this I can note that force on the conductor ABC is exactly equal to force on conductor AC. So if I take the combined force on AB and BC, that will be equal to force on conductor AC. That is the approach that we should have for this problem. Hence I can say F is equal to what? B into I into L. Okay. So as you can notice, I have already told you that length L would be, this is 5 centimeter, right? So this is 5 centimeter, as we can understand. So hence I can write 5 into 10 as per the given question. Magnetic field is 5 Tesla, okay, and current is 10 ampere, and length is 5 centimeter, and direction of the direction angle theta will be what? 90 degree here. So hence BIL sine theta is the formula, and in that I can comfortably write BIL sine 90, which is BIL. Okay, so B is 5, I is 10, current is 10 ampere, then length is 5 into 10 raised to minus 2. So due to that reason, we'll get the answer as 2.5 Newton. Okay, so 2.5 Newton happens to be option C here, my dear students. Are we clear on this? Any doubts? Any doubts we have on this particular solution? Let's progress to next question quickly. Third question. The coil of a galvanometer consists of 100 turns and effective area of 1 square centimeter. Okay. The restoring couple is 10 raised to minus 8 Newton meter per radian. The magnetic field between pole pieces is 5 Tesla. The current sensitivity of this galvanometer will be. So that is the question for us. So in order to crack this question, firstly, we should learn this particular formula here, that is current sensitivity is nothing but the angle of twist, that is theta divided by current, and we should remember that theta is NBA. Theta is NBA, okay, and that is equal to theta by I is equal to NBA divided by C here. So hence theta by I is equal to number of turns is 100, N is 100 here. So that is what I am marking. I am writing. Then B, magnetic field is 5 Tesla. So I am writing it as 5 into 10 raised to minus 4. Actually it's a typo error. It should be 5 into 10 raised to minus 4 Tesla. Okay. And C, that is the restoring couple, my dear students. It is 10 raised to minus 8. So if you just work this out, we tend to see that we'll get the answer as 5 radian per microampere. 5 radian per microampere. And the answer choice is option D here. Yes, okay. So I hope this particular approach is clear. Any doubts you have, I shall move on now. Let's move on to the next question, that is question number 4. A conducting loop carrying a current I is placed in a uniform magnetic field pointing into the plane of paper as shown. Okay, so this is cross magnetic field. So that means it is perpendicularly inward to the circle, to the screen. So thus the loop will have a tendency to. So let us try to understand how the loop will have a tendency, whether it will contract under this particular arrangement, whether it will expand, or whether it will translate towards positive x-axis or translate towards negative x-axis. These are the 4 options that we should cross verify. Okay, in order to do so, let's go ahead and consider net force on current carrying loop in uniform magnetic field is obviously 0. This is the concept that we must remember. So that means net force on a current carrying loop in uniform magnetic field is always zero. Okay, so due to that reason we can say that loop cannot translate. So translatory motion is traded off. Translatory motion cannot happen. So hence the current loop cannot move along x-axis or y-axis. So due to that reason we can say options C and D are wrong here. We cannot consider them. Now hence if you just observe in this particular region, current direction is clockwise. Okay, current direction is clockwise, and due to that, and magnetic field is perpendicularly inward here. So since magnetic field is perpendicularly inward, current direction is clockwise, as you can notice. Okay, current direction is clockwise and magnetic field is perpendicularly inward, so obviously force should be what? Outward. So hence I can comfortably say that Fm is going to act like this. Fm is going to act like this. That means radially outward. Now, will it not suggest that due to this radially outward force, there will be an expansion? So hence, we can say that from Fleming's left hand rule, we can see that if magnetic field is perpendicular to the paper inwards and current in the loop is clockwise, then force will definitely be Fm on each element of the loop will be radially outward, as I was mentioning it to you. So this is the direction of the magnetic field. So obviously it will be radially outward, and due to that reason radially outward means it will have a tendency to expand. Okay, so hence due to that reason right answer can be what? Option B here, right? So that is option B is our right choice, my dear students. We have learnt on this. Now let's go ahead and take a look at next question. Fine. So now we move on to question number 5. A metallic block carrying current I is subjected to a uniform magnetic induction B as shown in the figure. The moving charges experience a force F given by dash which results in the lowering of the potential of the face dash. Assume the speed of the carriers to be V. Okay. So here what we should calculate, firstly we should calculate the force, then we should calculate on what surface there will be decrease in the potential, decrease in the potential energy. So this is what we should go ahead and try to answer. So on what surface? So as you can notice in the diagram we have AC dB, okay, that is one. Then we have AE BG, that is one surface. So likewise there are many surfaces. On what surface we will have a decrease in the potential, and they have asked us to take a speed of the carriers as V. Okay, so accordingly I can redraw this diagram in this pattern. Okay, and as you can notice here I have kept surface ABCD, that is facing us, my dear students, here. So this is surface ABCD, and here is the charge at the middle. I have kept charge, that is electron. Okay, and here we have velocity V. Then we have magnetic field vector B, and we have electromagnetic force vector F. Okay, and this is the direction of current. Current will start from left and come out of the conductor in the rightward direction. That means it will come out of this surface. Okay, so it will come out of BDHG surface, my dear students. Okay, so hence as the block is made of metal, first and foremost thing we should remember it is a metallic block. So hence the charge carriers are definitely electrons. That is why I am showing electrons here. So for current along positive x-axis, now current is flowing in this direction, so it is positive x-axis, my dear students. We just take a look at this direction. The electrons are moving along negative x-axis because current and electrons will always move opposite to each other. From this we can comfortably understand this. Okay, so hence we can see that electrons move along negative x-axis, and due to that reason I can write velocity of the electrons as what? Vector v is equal to minus v into I cap, right? Because direction is minus I cap here, so hence it is minus v into I cap. Thus, and magnetic field will be along y-axis. From the rule itself we can say that if the current is along, if the electrons are moving along negative x-axis, magnetic field will be definitely along positive y-axis. Okay, so hence that will be vector b is equal to b into j cap here. Okay, fine. Next step. Now vector f is equal to, now this is a formula that I have learnt in moving charges, that is magnetic force F is equal to Q into vector V cross vector B. Okay, so from this I can clearly calculate the amount of force. So here vector V I know, vector B I know. Let me just go ahead and substitute them, and hence I can say vector F is equal to minus E. Charge Q is what? Charge on the electron, that is why it is minus E into bracket, we can write it as what? Vector v is minus v I cap, and vector b is b into j cap. Now what is I cap cross j cap, my dear students? Can you please reply here? What is I cap cross j cap? Quickly. Yes, come on, come on, come out with the answer. Okay, fine. Unfortunately, we are not having much time to wait for your answer. Okay, let me just consider vector f is equal to I cap cross j cap is k cap here. So from this I can very easily replace I cap cross j cap as k cap. Okay, so here we have k cap. Then E V B. So minus E into minus V, that will consume what? Negative sign. So thus we'll get E V B into k cap. E into V into B into k cap, because I cap cross j cap is k cap here. So from this I can comfortably say that k cap implies, if you just observe the direction of z axis here, this is the direction of z axis. So where will the force be acting? Will it not be normal to this surface ABCD? So hence I can say, as force on electron is towards face ABCD, the electrons will accumulate on it, and hence it will acquire lower potential. Okay, so surface ABCD will acquire lower potential because electrons will move towards surface ABCD, and force value is EVB into k cap. So thus our required answer is option A here. Okay, fine. So that's it. So this is the answer that we can get for this particular question. Okay, fine. Are we okay with this, my dear students? Yes, Siddhu. Okay, okay. K cap, you have answered, but I am unable to view your chats properly. Now I think I have made an arrangement here. Fine, very good to everyone. So now this is option A that we have answered. So obviously we are progressing to next question quickly. But prior to that, now my dear students, the time has uh, consumed half an hour time we have consumed already. Now it is 3:29. So obviously I'll be decommencing this class, okay, in my next session on YouTube live. That will be on 12th. Okay, on 12th I'll be continuing with the problems on this particular chapter. Okay, so I hope today's 5 questions that we have solved in half an hour has made you a lot of benefit. Okay, so you can watch the video repeatedly on YouTube. Okay, and for any queries, you please message in the comment line. I'll revert back to you. Okay, or else you can directly contact me, and please don't forget to attend my special classes as well. Okay, so with this note, my dear students, I'm ending today's session. So uh, are we okay with it? Are we okay with it? Yes. Okay, okay, Sonu, thank you. Prasanna, thank you. Uday, thank you. Sidhu, thank you. Soumya, thank you very much. So obviously, thanks for your active participation in today's session. I thank each and every student for your active participation. Thank you very much. Have a fabulous time ahead. Thank you, Deepa. Uh, Thank you, Sonu. So I'll see you back on 12th on YouTube Live. Okay. So until then, your teacher Uttam Kumar Umarji, I sign off. Thank you very much. Have a fantastic time.